Metals like iron, nickel, cobalt, and some of their alloys can be attracted by magnets, while those like copper, manganese, and aluminum are not. A magnetic bar has north and south poles, and they will orient in north-south direction if suspended in the air. That is because Earth's magnetic field, which also has a north and south pole, though they do not exactly correspond to the location of geographical north and south poles. Like poles of magnets repel each other, while unlike poles attract each other. There are invisible lines of magnetic force surrounding a magnet which decrease in strength as the distance from the magnet increases. They constitute the magnetic field surrounding the magnet. Similarly, Earth also has a geomagnetic field which is very important in radio communications. Geomagnetic storms resulting from sudden spurts of solar activity can disrupt radio communications globally, as we had in May 2024. Iron, nickel, cobalt, and some of their alloys are ferromagnetic materials. They can be magnetized and they retain the magnetic properties once magnetized using a magnetic field. These ferromagnetic materials are used to make permanent magnets. An alloy of iron, aluminum and nickel called alnico is one of the strongest permanent magnetic materials. Very often, screwdrivers are magnetized and help in attaching screws without having them fall off while trying to fix them. Magnetic flux is the entire group of magnetic lines from the north pole to south pole of a magnet and is measured in Weber units. Magnetic field lines per unit area of a section perpendicular to the direction of the magnetic flux is known as flux density and is measured in Tesla units. Permanent magnets are used in loudspeakers, headphones, and measurement meters. Coils kept inside the magnetic field get energized by electromagnetism and move while in the field of the permanent magnet, producing sound in case of loudspeakers and measurement needle movement in case of meters. Electric current passing through a wire produces a circular magnetic field around the wire. The intensity of the magnetic field decreases as the distance from the wire increases. Direction of the magnetic flux lines can be found by the left-hand rule. When the conducting wire is grasped by the left hand, curled fingers point to the direction of magnetic flux lines and thumb shows the direction of current flow. Electromagnets are used in various ways in electronics and amateur radio. Transformers are working by the principle of electromagnetic induction to transform voltages and impedance in radios. Impedance matching transformers are used in antenna systems. Step-down transformers are used in linear power supplies. Electromagnetic relays are widely used in radios. When you press the push-to-talk (PTT) button on a hand mic, relays are energized to switch the radio from receive mode to transmit mode. Automatic antenna tuners use electromagnetic relays to switch between different combinations of inductors and capacitors to tune the antenna circuit. In the schematic of the relay shown, when the coil is energized by a current flowing from A1 to A2, it pulls the magnetic strip towards the electromagnet. That causes the switch to close and make contact between terminals 3 and 4. Reverse occurs when the current stops flowing. A low voltage in the electromagnet can also be used to switch a high voltage circuit using a relay so that there is no chance for the operator to come in the vicinity of the high voltage. I had such relays in my radio using vacuum tubes long back when the plate voltage of the final vacuum tubes were in the range of 800 volts. Switching was done using a 12 volt circuit coming to the push to talk button of the microphone.